I think I don't want to say anything because we'll all learn, but I'm really missing him. And first, I'm handing over to our director, Professor Ravindran, who was part of organizing committee also, to say a few things.
Okay, so thanks, Wednesday. So let me welcome all of you to our institute, IMSC. And I always take this opportunity to actually say a few words about IMSC because there are people who are the first comers, to this institute. So IMSC, as you all know, it's a premier institute doing research in 4 different areas: theoretical physics, theoretical computer science, mathematics, and computational biology. We have quite a lot of faculty members, about 50 faculty members at present, and about 120 students. Very vibrant institute, as you will see, in next 3 days. We have very good library, and also computational facilities. And I'm happy that you are all here. I think it's after COVID, we have this big meeting in ionity physics. There are many meetings that are going on for last 3 years after COVID. And this meeting is very special for IMSC because actually this is to honor one of our beloved colleague. For me, he was a teacher and later happened to be in the same corridor where he used to sit. So it is about honoring Professor Rajshekaran, fondly called Rajaji. And I joined this institute in sometime in 80s, I think, end of 80s, and he was the joint director. And he looked exactly same when he passed away, very look-wise, and also as a personality, as a mentor, as a visionary, as a scientist, and also a person who guides everybody. He was like a fatherly figure to most of us, and particularly to me. And I'm really happy that I'm part of this team to sort of have a 3-day program to honor, because he always liked physics. And like Manjari said, we have been missing him a lot. Okay, thank you. I have to chair, okay. So I think I said quite a lot about Rajaji, and you will hear more from Professor Murthy, who had a long association with him, more than I did actually. So I will request Professor Murthy to actually talk about him. I don't think you need an introduction to Murthy. Murthy was our former professor at IMSC, particle physicist, as you all know. And he had also had a long association with him. So
Thank you very much. And it's a pleasure to come back and meet all the old friends, and especially Neeta and Rahul, who are not in Chennai anymore. And so this is a tribute to Professor G. Rajshekaran, whom we fondly called as Rajaji. So I will refer to him as Rajaji throughout. And the title of the talk is taken from the title of his autobiography, which is My Inward Bound Journey. I'll give a reference to that autobiography later. Even though my bias may show in this talk, much of what I am going to say is taken from the autobiography itself, some of them in his own words. So, and of course I sent it to some of his old friends like Divakaran, Mani, and others who also commented on this and gave me some information about Rajaji, which I have included. So let me continue. So this is the outline of the talk. It's more like a biography of Rajaji, a scientific biography of Rajaji and his achievements. So growing up, then his scientific contributions, there it will be a selection because it's huge. And then I'll talk about rebuilding IMSC. We are sitting in this hall and we should know what all he did for this institute. It's enormous. I mean, especially the young people, young IMSC people should know that. And then back to research, and he worked on the India-based neutrino observatory project, and his contribution to teaching and outreach. This is how I have organized it. And his early years, he was born in 1936 in a very small town called Kamudi in the Ramnad district. Now it's called Ramanathapuram district in Madras Presidency. He is the eldest of 5 brothers and 4 sisters, and his father owned what we call as Patrakadai, which is a shop selling vessels. And he went to school in those days, primary school, middle school, and high school, all in Kamudi. And after 10th, next 2 years were spent in American college, and that was called as intermediate in those days. Now it is 11th and 12th, plus 2, as you call it. And when he was in American college, he came to use the telescope that was in the college. And he gushes about the first view of the moon that he saw through the telescope. And that kind of initiated his deep interest in physics. And then he went to do the BSc Honours in Physics at Madras Christian College. While he was at Christian College, there was this Professor Tangaraj who had research projects with people in TIFR. Professor Bernard Peters, who in the 50s was in Tata Institute of Fundamental Research, M.G.K. Menon. All these people used to come to Madras Christian College and do these cosmic ray experiments, sending balloons. And they needed a lot of students to help in this, because the balloon would go up to a certain altitude. After some time, it would die down. So they have to fetch the instruments back. And all these college students were helping them in these experiments. So Rajaji came in contact with these people. And not only they came here to do experiments, they used to give talks in the college. So that kind of was an inspiration for Rajaji. And then he went to join the Atomic Energy Establishment Training School. It was not BARC at that time. It used to be called Atomic Energy Establishment Training School. And this was in 1957. He went to join this Atomic Energy Establishment. In the first batch, there were about 150 trainees, engineers, chemistry, physics, and I think that's probably what they had in the first batch. And then after completing the training, 1 year training in the training school, he joined TIFR, and he was first among the 150 trainees in the first batch by a distance. In fact, he got the gold medal on the 50th anniversary of the training school in 2008 from Prime Minister Manmohan Singh at that time for standing first in the first training school. And since they had a choice, or he had a choice, he joined TIFR in 1958, and up to 61 he was in TIFR. He started working on hypernuclear physics, which was one of the fields at that time which was at the forefront, and B.M. Udgankar was one of the people who was involved in that, and then he started working on this. And then he also got interested in digging deep into quantum field theory. He learned quantum field theory from S.N. Biswas, many of you may have heard about him, and L.K. Pandit, who had just joined Tata Institute of Fundamental Research at that time. So at this time, Rajaji had started supporting his family because his father had to actually take a lot of loans for his education. And when he was in TIFR, he was supporting, and he ensured that the support would continue even when he went to Chicago for his PhD. So here is the photograph. This is a very famous, I consider it as a very important photograph because it contains so many people that we know who later contributed to development of physics and science in various other places, including popularization of science, like M.P. Parameswaran, who is in this, I think this is M.P. Parameswaran. He is the one who started this Kerala Shastra Sahitya Parishad. And it also has, apart from Rajaji, my other collaborators, C.V.K. Baba, who is here, and K.V.L. Sharma, who was one of my advisors too in my thesis work. So there are many illustrious names in this, and this is a photograph which one should keep. It's good for any archive. And he joined TIFR after the training school. It was a norm in TIFR those days that after spending some time in TIFR, they would go and do their PhD. They were encouraged to do their PhD in some very good places. And at that time, Rajaji in 1961 attended the TIFR summer school in Bangalore, where the lecturers were Gelman and Dalits. And this was actually the summer school in which Gelman for the first time talked about SU3. Though he did not introduce the quarks at that time, he talked about the eightfold way and the octet baryons and the decuplet baryons in that meeting. And in fact, Rajaji mentions that Dalits kept asking him the question, what about the fundamental representation of SU3? Where is it? So, but one had to wait for 2 more years to see that fundamental representation appear in terms of the quarks. So, after encouraged by Dalits, whom he had met in this TIFR summer school in 1961, Rajaji went to Chicago. And it took 3 months on the ship to go to Chicago. So he studied and prepared for the Chicago basic exam. It was a dreaded exam apparently. And by the time he reached, he was already ready to take the exam. So within 2 or 3 months after going to Chicago, he took this Chicago basic exam and he topped the exam. And I heard from Divakaran that stock of many Indian students went up because of Rajaji's performance in this Chicago basic exam. And he did something else along with doing research with Dalits. I'll come to that in a little while. A.K. Ramanujan, I don't know how many of you heard of his name. A.K. Ramanujan is one of those people who was actually one of the founders of the South Asian School in Chicago. And he was the translator and interpreter of many Tamil and Kannada epics. He translated Kannada epics into speaking of Shiva, and then Tamil Sangam literature like Stilapadikaram and Manimekalai were translated by him. But since he grew up in Mysore, his Tamil was not great, and it was Rajaji who helped him. Rajaji's knowledge of Tamil language and literature was very good, and it was he who helped A.K. Ramanujan in translating and interpreting this Sangam literature. And I think this was the very first time when the Sangam literature was brought into English in full. So, this is about Rajaji's education and his growing up. So, coming to his contributions, scientific and also otherwise, Rajaji is like a big banyan tree, So many branches are there, so many things he did. And for example, he wrote research-wise, there are more than 200 papers, more than 20 reviews. He contributed to rebuilding of IMSC and teaching at every level, science outreach in English and Tamil, mentoring young scientists, contributions to other institutes, and to the development of underground science laboratory, which is still in works. And all this was done, from his journey, starting from Kamudi, Madurai, Madras, Bombay, Chicago, Oxford, again Bombay, Madras, and Keck in Japan. And I have left out many other places that he went to, but these were the places where he spent at least more than a year. So it's hard to cover these things in the next 30 or 40 minutes. So I have to make a selection, and that is necessarily biased. So in his thesis work, which was done in Chicago first, and then last 1 year was spent at Oxford, he worked on what are called as the shadow poles. So after the SU3 model of Gelman came, Yang had a serious objection saying that it has to be wrong. Because for example, if you look at the SU3 octet or decuplet, they are not degenerate. Now, they appear as poles on different Riemann sheets in the S matrix language. And obviously, in the symmetry limit, they have to collapse into a single pole, and that did not happen. So Young and Oakes commented that this has to be wrong. And this problem was solved by Rajaji and, of course, with Dalits, where he showed that there can be a retinue of poles, even in the symmetry limit, and these are called as the shadow poles. And that solved this problem and removed the objection to the very basic objection to the SU3 of Gell-Mann. So this was a formulation which also kind of led to the reformulation of the basic tenet of S matrix theory. So Rajaji completed his thesis in just under 3 years. After spending a year in Oxford, because Dalits, who was on sabbatical in Chicago, went back to Oxford, and Rajaji also moved to Oxford with him. And he returned to TIFR in 1964, just after submitting his thesis. So he had not completed his defense, and his defense was actually conducted by post. So today, even we do, online, many people try to object. But those days it was done by post. The committee was headed by Telagdi, and he was sent questions by post, and Rajaji answered the questions by return post, and then he was awarded his PhD by University of Chicago. Then the next work that he did, which he started doing while he was in Oxford and completed after coming to TIFR, is a very interesting work. And it's also a bit audacious. And this is a work which I like very much, because it's still an open problem. And it looks like the solution given by Rajaji and Dalits at that time is actually the correct solution. So the problem is the following, that if you look at the nucleon and its excitations in the hadron, in the baryon spectrum, okay, so you will see that the ground state is, of course, the neutron and the proton, as we know, at 940. And the first odd parity excitation is a half minus state at 1535 or 1.5 GeV, slightly above that. And there are two problems here. In the SU3 limit, of course, nucleon and lambda, they are all in the same octet. But if you look at the first excitation of lambda, which is half minus, similar to 1535 here, this is at 1405, and this difference is only 300 MeV as opposed to 600 MeV excitation energy. And this is actually, odd parity has to be the first excitation. The ground state is even. Two problems. There is a Roper resonance which is an even parity excitation, and if it's a radial excitation of the nucleon ground state, then it has to be much higher than here, about almost around 1000 GeV above the nucleon. And in fact, instead of first odd parity state coming before the radial excitation comes before that. This is an open problem in QCD, where Roper resonance has not been fully explained. And there are many solutions to that, and have been proposed, but none of which is confirmed. So these are the two main problems, and Rajaji actually proposed that this lambda 1405 is not a 3-quark state at all. It has to be a molecular hadron. Only then it can come so low. There may be an admixture of the quark state, but what makes it come down is the molecular state. That it's actually a bound state of k bar n, and it is not a pure 3-quark state. So this, in the 60s, it is an audacious suggestion that this is a molecular hadron. And now, of course, people are thinking that Roper resonance may also be a molecular hadron, or probably a highly deformed state like in nuclei, which comes down due to the deformation. So now in the last few years, there is a growing evidence from lattice QCD calculations that this is indeed a baryon molecule or a hadron molecule. So what Rajaji did in the 60s is now coming back, and the solution proposed is coming into prominence. In fact, this is in the physics news. I think this was in 2017 or 18. In the 1960s, the Australian physicists Richard Dalits and colleagues, actually it should be Rajaji and colleagues, because Rajaji was the first one to propose, and then they wrote the paper together. In fact, Rajaji presented it presented the proposal in high energy physics conference at Aligarh AMU, Aligarh University. So so the statement here is Richard Dalitz and colleagues suggested that lambda 1405 could comprise of an anti-kaon meson bound to nucleon. So these calculations now today they are increasingly getting accepted. In fact, there is a magnetic moment calculation which shows that the strange quark does not contribute to the magnetic moment of lambda 1405, and that is possible because it is bound inside k bar, and that's a pseudoscalar. So therefore, it does not contribute to it cannot explicitly contribute to the magnetic moment. And this, in fact, it's interesting that this work was done by Derek Lineweber et al., whom we knew as a student from McMaster University. Even Rajaji knew him. So he is now a professor at Adelaide. So next, Rajaji's interest shifted to, after coming to TIFR, after the paper by Weinberg and Salam, he shifted interest into gauge theories. He was an early proponent of the gauge theories. His lectures delivered at Saha Institute in 1971 and also in some other places was the first coherent account of the Yang-Mills fields and the Salam-Weinberg electroweak theory. And this is unpublished. It's a TIFR report. And this is well before, this electroweak unification became a paradigm for high-energy physics. So his lectures were attended by quite a few people. And the notes even contained his conjecture that massless Yang-Mills gauge quantum cannot exist freely because of the infrared divergence. One should remember this was in 1971 when QCD was not yet there. And here is a statement by Pakwasa, who attended these lectures. He said, I got hold of his lectures on Yang-Mills theory given at Saha Institute. No, he didn't attend. He got hold of the lecture notes. And he says that became his Bible. I still have my marked up copy, dog-eared copy, and this contains prescient remarks about confinement and other ideas. And similar sentiments were also expressed by Lalit Sahgal, who actually attended these lectures. Perhaps Rajaji's best work in this connection, even though he didn't publish anything, he didn't do the development of gauge theory, was that the very first calculation which showed the finite contribution at non-leading order after Etouff's general theory, it was, I think, the first paper which showed the finite non-tree level computation in the standard model in the case of muon decay. This was not the one which was published first, but I think that was one of the earliest calculations to be done using the standard model or electroweak model at that time. So the electroweak gauge theory was not taken seriously until the discovery of the neutral current in 1973. So all of Rajaji's earlier work was before the discovery of neutral current. Now, after the discovery of neutral current, so I don't know how many of you remember, that the interest in Weinberg-Salam theory just went up. It shot up. Because that was one of the predictions of Weinberg's paper. In fact, when they saw the neutral current event first, they called it as the Weinberg event. Okay. So immediately then Rajaji combined with KVL Sharma, and they wrote the first model independent analysis of the deep inelastic neutrino scattering data. And the equations that they developed for getting the limits, etc., were called as master equations by Sakurai, who further developed further built up on what Rajaji and KVL Sharma did. Series of papers were followed, both by Rajaji and KVL and also Sakurai and others, which ultimately led to the complete determination of the neutral current coupling constants in isoscalar and the isovector sectors. And in fact, this was necessary to establish Weinberg-Salam model as the template for the standard model later. So 70s decade was a very productive one. Rajaji et al. Worked on the phenomenology of electroweak model, which became the standard model later with the addition of QCD. There is one regret that Rajaji expresses here, that he could not contribute substantially to the early development of electroweak gauge theory. He says that although I missed being on the stage, I sat on the front row. There was no bitterness in this statement, and later on he did contribute substantially to the development of the standard model. He never said it as an excuse, but I found out that by talking to other people, Rajaji's father was very ill at this time, and so he had to go up and down and travel a lot to take care of his family matters also. So might have, but this was never given as an excuse by him or even mentioned. So in 1974, Rajaji thought that after all this hard work, he will take a holiday and go to Hawaii. And he was invited by Sandeep Pakwasa to visit Hawaii for a few months. So in fact, Rajaji wanted to combine it with a holiday, so he took the whole family to Hawaii. But a day or two after landing in Hawaii, suddenly comes this announcement of narrow resonance in E plus E minus collisions at 3.1 GeV. This is the JPSI, which created a lot of excitement at that stage, at that time. And for the next few days, he didn't have any peace. He, Pakwasa, and Tuan sat and worked out all possibilities, whatever possible explanations of this bump. Something like 10 explanations were worked out for this 3.1 GeV bump, one of which was actually the correct one. So they exhausted all the things, including the correct one. And it was one of the earliest of many similar papers. It contained an exhaustive list of interpretations, including the correct one, as Rajaji says. In 1976, Rajaji moved to Theoretical Physics Department of Madras University, which was one of the finest departments at that time, headed by P.M. Matthews. And in fact, TRG is here. He was there in that department when Rajaji joined. And along with Matthews, Sitaraman, and Bhamati, Rajaji also joined this department, which really flourished with the addition of all these people. I'm not too familiar with the work done in Madras University because it related to, at that time, what was a distinct possibility, that is the integer quark model. So they spent a lot of time, especially with Rindani, who had joined as faculty in 1978. They did a lot of work on how to observationally distinguish the fractionally charged quarks and integer charged quarks through experiments. There are more than 20 papers. Just to summarize what he did in Madras University in those years, for example, there is this equivalence of Parisi model with confinement in QCD. Rajaji considered this as a very nice paper. This was done with V. Srinivasan and later with M.S. Sriram. And then the remarkable properties, here he moves to integer charge quark models. It begins with the paper by Prabir Roy and Rajaji. Remarkable properties of both broken color QCD with integrally charged quarks. Then they went on to devise many tests using in these jet experiments. And this was done with two of his students, Jayaraman and Lakshmi Bala, who have distinguished themselves in various other places already. And then the discovery, this is an important paper, discovery of new effects invalidating the time-ordered equivalent photon method for the production of charged particles of spin greater than half. This is one of the things which was stated almost like a theorem, this equivalent photon method. Whenever you have electron interaction, the virtual photon can be replaced by a real photon, and you can, where it's forward scattering. Then it's almost close to be on Marshall. And so you can replace it by as though it is the photon that is initiating the interaction. This is the equivalent photon method. So they showed that this is valid only for massless spin 1 particles, and it's not valid when the spin 1 particle is massive. I think that was an important thing. So his collaborators, I mentioned the names of all the collaborators during this period. I think Srinivasan, Rindani were his colleagues. Lakshmi Bala and Jayaraman were his students. M.S. Sriram, Jatindra Bajaj were on his project. He had a big UGC project at that time, and they worked with him on the project. And later M.S. Sriram joined as faculty. So coming to Math Science, he moved to IMSC in 1984. And his focus shifted to neutrino physics. I remember when I joined, Joshipura had joined just before me. He called both of us to his office. And then he just put Bethes paper in front of us and then said that, look, this is the Bethes solution for solar neutrino problem. So it's a beautiful paper. You read it. And then this is still a toy model because it is done for 2 generations. See if you can do it for 3 generations. So that is how my collaboration with Rajaji and Joshipura began at that time. And then we continued that collaboration after Mohan Narayan joined me as student and Uma Shankar was my colleague. So together we, after the discovery of neutrino oscillations, we were one of the first to do a comprehensive, realistic 3-generation analysis of solar and atmospheric neutrino data to pin down the range of parameters. So at that time we got both large angle and the small angle solution. The region for small angle was actually getting narrower and narrower, and it was a small angle solution that, large angle solution for theta 2,3 that survived from that time. But the elements of the correct solutions were already there in our analysis at that time. Now, having started this full 3-generation realistic analysis, we also extended it to supernova neutrino emission along with Gautam Datta, Indumati and myself. And this, in between with Rahul Sinha and Balaji, he also did this analysis of day-night effect with solar neutrinos. At that time, it was still an open question, and they showed that there is not much difference. And they also looked at this very interesting eclipse effect. So all this was done in the realistic 3-generation framework. And a corollary of that is this very important and notable contribution at that time. When the choose reactor neutrino analysis, the neutrino data came, their initial analysis was using the 2 generations. And obviously, if you use 2-generation analysis for choose data at a smaller distance, you don't find any result. It was a null result. So that analysis was completely wrong. And Mohan Narayan and Rajaji and Uma Shankar did the full 3-generation analysis where the choose data actually put a limit on the theta 1,3 angle. At that time, theta 1,3 was not known. Nobody had an idea of what its value should be. And this was the first determination of the theta 1,3 angle. And they showed that this third mixing angle has to be less than 12 degrees using the choose data. And they wrote to the experimentalists saying that you have a beautiful result and your analysis is wrong. So immediately the choose people changed their paper, did the full analysis with 3 generations, and then that paper, that's the first one in which we have any idea of what theta 1,3 should be. It's a limit, it's not a determination of the angle, and the limit was 12 degrees. When the paper was published, even after revision on the archive and later when it was published, there was no mention of this information which was conveyed to them. And it's very clear that immediately after this conveyed, their preprint changed, and then the published version changed. There's absolutely no acknowledgement of the contribution from Mohan Narayan, Uma Shankar, and Rajaji. This keeps happening. One should be very aware of these things. And now we have confirmed this analysis, this by actual determination of this angle from Diabe and Reno. This is about 9 degrees, well within this limit. Okay. Here are all the collaborators from this period in the 90s. And later on, Rajaji constructed the mass model with F4 symmetry. Actually, it became a very well-known paper. This he did with Ma. They actually constructed a mass model which which gave a neutrino mass matrix based on a symmetry, which is the A4 symmetry. And he also looked at how to generate neutrino masses, and a new mechanism was arrived at, but in which Higgs will becomes a composite, and this was done with P.P. Divakaran. And he also looked at the evolution of neutrino parameters from the unification scale down. So because you have a mixing matrix for the neutrinos and you have a mixing matrix for the quarks, and they are very different. Why are they so different? So if you assume that they are very similar at the unification scale, then you can do the RG evolution backwards and show actually that the neutrino mixing angles can be what they are in principle. So this work was done with Parida, R.N. Mahapatra, Sanjeev Agarwala, and there are many other collaborators. This he almost continued till 2 years ago. He was still working on such problems. So in the 60s and 70s, there were many anomalous events that were observed in Kolar goldfields, and these were called as Kolar events. These are events in which the event took place in the air, and then if you gave 2 prongs or 3 prongs in the proportional detector, so by working backwards, you could identify the vortex in the air. Now, at 2.7 kilometers underground, neutrino interactions in air cannot give you 8 events in about 20 years of running. So this was a puzzle, and these were called anomalous Kolar events. They have not been withdrawn, so they must be there. And these events were reinterpreted as possibly due to dark matter, because there are only 2 possibilities at that depth of 2.7 kilometers, either neutrinos or dark matter. So an interpretation was arrived at saying that this is due to the decay of dark matter. There are a lot of problems with this interpretation also, but nevertheless that conundrum is there. I mean, what else can it be? So, and proposed an experiment at INO to confront this hypothesis with Datar, Indumati, myself and Satyanarayan. There are still many problems with this interpretation, but it just shows the kind of adventurism that one has. So there are other contributions which I am not very familiar. Rajaji and A.K. Mishra discovered new forms of quantum statistics, such as ortho, null statistics, etc. Their theory of generalized Fock spaces enlarged the framework within which familiar quantum field theory and statistical mechanics reside. And then he also looked at Arnaud-Bloom effect in Kaluza-Klein theories, extended to include Berry phase, etc., with R. Parthasarathi and R. Vasudevan, and consequences of non-commutative standard model for physical processes with many other collaborators. I'm not too familiar with these things. How much more time I have? 10 minutes, okay. So, now I'll come to moving away from his research, come to his contribution to rebuilding of IMSC. Professor Alladi Ramakrishnan was founder director of IMSC. He retired in 1983, and IMSC was looking for a new director. A committee consisting of Vice Chancellor of Anna University, Kulundeswamy, B.M. Udgaonkar and M.S. Narasimhan actually proposed Rajaji as the director after Alladi Ramakrishnan. Unfortunately, a change came about, and Rajaji was requested by Ramana to take charge as joint director and not as director, and not as deputy director. And his letter of appointment clearly says that during the director's absence, the joint director shall have the full powers of the director. Rajaji was initially reluctant, and then he agreed, and along with Professor Sheshadri went about rebuilding IMSC. So here are various things that he did, which are very important for later development of IMSC. One, of course, we didn't have the land across where many of you are staying in the guest house. So he worked with, with the help of Kulundai Swami, who was the Vice Chancellor of Anna University, and using his contacts with Ranganayakam at that time, Education Minister, he got the land for our hostel and the guest house facilities within about 3 to 4 months' time. That was quite remarkable at that time that he could get that. And then we started building the hostel and the guest house at that time. Still a smaller facility, not like today. And then second important thing, this happened just before I joined the institute in 1986, is the shift to the central government salary structure, because by that time the institute was almost fully funded by the Department of Atomic Energy. So he convinced DAE that all DAE institutes should shift to the same central government salary structure and service benefits for the faculty and also the administrative members. This had actually much larger effect than just IMSC, because immediately IOP also got the same thing. And then when HRI started, from the beginning they had uniform central government scales, which is very similar to all other institutes under DAE. And with that, one could attract talents. And within about 4 years, from 84 to 88, the faculty strength, which was about 12 in 1983 when Alladi Ramakrishnan retired, went up to 31, attracting many brilliant young minds in mathematics and theoretical physics from all across the country and abroad. And he also laid the foundation for graduate school at IMSC. In fact, we were all involved in that effort. When I say Rajaji's contribution, he was the leading member of all these things. There were many other people who were involved also. And this graduate school started at around that time. And for the first time, this MSc by research was also started. And at that time, I think we were the first ones to get it, to start an MSc by research program. And no university was prepared to give this MSc by research degree. So, in fact, Rajaji was made a member of the Senate of Anna University so that he could propose this, and Kulundai Swami, who was the Vice Chancellor, also supported it, and that's how the MSc in research started. Then starting of theoretical computer science research program with very young faculty members. This is quite a daring move at that time. And in 2001, Rajaji retired formally from IMSc, but continued to work as emeritus professor till the end. Till last year when he passed away, he was there. And most of this period was consumed by his effort in creating a world-class underground laboratory. This is still a work in progress. So many Rajaji's friends and others came to attend this festival, where we discussed in great detail and produced a report on construction of a deep underground national laboratory. So this here, we have to remember that India was a pioneer in neutrino experiments. One of the very first underground laboratories in the world was at KGF. And it was also the deepest as long as it was operational. The very first observation of the atmospheric neutrino event in 1965 was observed in KGF. In fact, here I would like to point out that Nobel Prize has been given to the observation of neutrinos from the sun, supernova, reactor, and the laboratory neutrinos. What is missing is the atmospheric neutrinos. This is a bit strange, and I think it was a pioneering effect which should have been recognized. I don't know, it's not recognized, that's all. Not recognized at that level. So Rajaji got involved in this from the very beginning, along with many others. But it was during his lifetime, it didn't come about. There was a lot of problems. So the initial support, which was great actually, from the time Tamil Nadu government before 2012, turned to apathy by 2015, and finally the support evaporated in 2020 after more than 2 decades of work from nearly 100 scientists, engineers, students, and even many officials who supported the project at both state government and the central government level. Rajaji was involved in every one of the activities of this underground laboratory project. In fact, you can see in these photographs, he's walking through all these fields, going up and down the streams and the mountains there at the site. Okay, 5 minutes. I think I'm more or less there. So, contribution to other institutes. This is, of course, very well known that while working in Madras University, he was the head of the department from 77 to 80. He was in charge of the physics group and the physics teaching at Chennai Mathematical Institute when they started the physics program in 2002. Served on governing councils of national institutions, syndicates of universities, and also review boards of many universities. He was there. Served on many committees of science academies and committees of DAE, DST and UGC and various other institutes. He has been honored. He is a fellow of all the 3 academies, recipient of Meghnad Saha Award and SN Bose Medal of INSA. And teaching and public outreach was always there for Rajaji. Apart from regular teaching at TIFR and Madras University, IMSC and CMI, Rajaji was involved in very multifold activities, running and teaching in most successful DST, SCRC schools in theoretical high energy physics. This was started with Mukunda, then continued with Rajaji, and initiated physics teaching for talented students, which is still going on. And the Sunday classes in Madras University, with the help which was started with M.V. Satyanarayana, who just passed away a few months back, of Pondicherry University. It completed 25 years. Every Sunday, Rajaji, when he was in Chennai, he would go there and spend 3 hours teaching the students. And the students came from all over southern Andhra Pradesh, southern Tamil Nadu, and of course Chennai. Okay. So then conducting refresher courses for which Indu, me, Rajaji, we have gone as a team to so many places in TN, Kerala and Karnataka. And this was supported by the Academy of Sciences. And then public outreach for INO. Here we have gone from research institutes to officers of the state government, to tea stalls in the villages. Where if somebody says that we didn't do outreach correctly, I think they don't know what all we have done. So, and Rajaji was there. In fact, especially while speaking to villagers in tea shops, etc., he could speak Tamil fluently, and that was of great help. And we have gone through many places in various states for this public outreach. Then he started writing in Tamil because he wanted to reach a larger audience. He started writing. First he started writing about neutrinos, then extended it to all of science, and then wrote many articles in Tamil every month to the Tamil magazine. It was edited by Dr. Jayaprakasam, and all the articles are now collected as in the book form. So he was an eternal optimist. For example, Rajaji, he believed that the underground lab project will be built. He said it will be built. We will keep working. And that was in fact one of our great motivations to continue to do it. Apart from directly working on site surveys, I don't know, he involved himself in every possible activity regarding that, including of course doing the physics goals for ICAL with Indumati, Nita and myself. And he also attended every meeting, every collaboration meeting, not just of ICAL collaboration, of this NDBD collaboration, dark matter collaboration, and participated in every one of the futuristic laser plasma accelerator discussions. He brought many people to collaborate with Indian groups, was extremely keen on universities participating, even taking lead in many projects. More importantly, wanted mega projects in science to take off, especially in remote areas, to inspire students locally to take science and contribute to growth of science and technology within the country. So he has been an inspiring leading member of physics community in India, lived an honest, candid and simple life in science and in everything. This is his family, his 2 daughters, grandchildren and his wife Sadantra, who is sitting next to him. So I think I'll stop here. The sources I said I'll give. This is available. Rajaji's autobiography is in Google Books. Anybody can download it and read it. And then there is a Rajaji Fest Proceedings, which is available as an IMSC report. This was edited by Indu Parthasarathi. And you can also go to his memorial website if you want to add anecdotes, your own stories, or you want to add pictures, please do so. So, thank you very much for listening.
Thank you.